A, B, X, and Y are positive real numbers. X is less than A and Y is less than B. We are interested in this inequality involving the gamma function. Gamma of X plus Y times gamma of A plus B is greater than or equal to gamma of X plus B, gamma of A plus Y. Now, note that this side here is like this side with Y and B swapped. We will prove a general inequality that will help us in handling this inequality here. So we have three functions, alpha of u, eta of u, c of u. They are defined for u from 0 to 1. Function alpha is non-negative, and the two functions eta and c have opposite monotonicity, which means that if one of them is increasing, the other is decreasing. So if we choose u to be greater than v, because eta is increasing, then this difference here will be non-negative. But because c is decreasing, then the difference cu minus cv will be non-positive. So a non-negative number times a non-positive number is non-positive. So the product here will be non-positive. Now, if u is less than v, then eta of u minus eta of v will be non-positive, but cu minus c of v will be non-negative. The product is still non-positive. And if u is equal to v, then this product will be 0, and 0 is less than or equal to 0. Now, if we switch the roles of eta and c, if eta is decreasing and c is increasing, we will get the exact same result. So this inequality here, that eta of u minus eta of v in a bracket times c of u minus c of v in another bracket, this is always the product of a non-negative quantity and a non-positive quantity, and the product is non-positive. And this is true for every u and v living in this closed interval from 0 to 1. Now, function alpha is non-negative, and so multiplying this inequality by function alpha will not change the inequality because we are multiplying by a quantity that is non-negative. So we will multiply by alpha of u and alpha of v. So this is the inequality that we have. The next step is to integrate both sides of this inequality with respect to u and v, each from 0 to 1. Now, the integral of the right-hand side is exactly equal to 0. While the integral of the left-hand side, what we'll do is that we will expand. So we multiply the two brackets, we'll get 4 terms, and when we integrate, we will get 4 terms here. 2 of them are the same. So for example, this term here, this is integral 0 to 1 alpha of v dv, and here this one, it is just the same integral. You know, the variable of integration here is u, here is v, but it's the same thing. And the other integral will be the same. And these two middle terms will also be the same. So we can, combine the equal terms and divide by 2. So we eventually reach this inequality here, which involves functions alpha, which is non-negative, and functions eta and c, which have opposite monotonicity. Okay, so this is the general result. To get our inequality regarding the beta function, so the way to obtain the beta function, we will use the gamma function, we will use the beta function. Okay, so we know that beta of m comma n is gamma m gamma n divided by gamma of the sum. So the beta function is related to the gamma function, and the beta function, it has several integral representations. One of them is that beta m and n is an integral from 0 to 1, t to the power m minus 1, 1 minus t to the power n minus 1 dt. And so basically this is the function that we will use in our way to prove the inequality for the gamma function. And to do this, we will strategically assign, we will make choices regarding alpha, eta, and c. So alpha of u, we will choose it to be u to the x minus 1, 1 minus u, y to the minus 1. And, from the choice here, it is a non-negative function. Now, eta of u is u to the a minus x. Note that the exponent here, or the power, is positive because x is less than a. And it's u to the power of positive power, and here this function is increasing. Now in C of u, the power is b minus u, which is also positive because y is less than, sorry, it's b minus y, and the power here is also positive because y is less than b. But note that here we are using 1 minus u, and so C is a decreasing function. So alpha is non-negative, and these two functions, eta and C, are of opposite monotonicity. And this is enough for us to be able to apply the general inequality. So we will insert, the alpha and eta and C in this inequality here. Now, alpha will be this integral. Now, this integral is beta of x comma y. The other inequality, the integrand is the product of alpha, eta, and C. So if we multiply these guys together, we get u to the a minus 1, because we have u to the x minus 1 from here. And from there, we have a minus x. So the x's cancel, and we have a minus 1. And for the 1 minus u here, it is raised to the power u minus 1. Then it is multiplied by this guy, and we have b minus y. So y is eliminated, and we have b minus 1. And so we have integral from 0 to 1, u to the a minus 1, 1 minus u to the b minus 1. And this is basically, when we integrate from 0 to 1, this is beta of a comma b. Now for the other side, we will do the same. We will put our choices for alpha, eta, and C. Now here, we can combine these two guys as u to the a minus 1, and this one is 1 minus u to the y minus 1. This is beta of a and u. And for this one, we will get u to the x minus 1, 1 minus u to the b minus 1, which is beta of x and b. That's it. Just apply the inequality. So beta of x comma y, beta of ab, which is this, is less than or equal to that by the inequality that we have proved. So this is an inequality that we have for the beta function. We obtained it along the way. Now to get our desired inequality in terms of the gamma function, just express each beta function in terms of the gamma function. So beta xy is gamma of x, gamma of y over gamma of the sum. And beta ab is gamma of a, gamma of b over gamma of a plus b. Now on this side, this one will give us in the numerator gamma of x, gamma of b, and this one in the numerator, it will give us gamma of a, gamma of y. And so in the numerator here on the left-hand side, we have gamma of a times gamma of b times gamma of x times gamma of y. And we have the same 4 terms multiplied together in the numerator of the right-hand side. And so, and none of those terms are equal to 0. So those basically will go. And we are left with the denominators. And so we can basically take the reciprocals and change the inequality. So gamma of x plus y times gamma of a plus b is greater than or equal to gamma of x plus b, gamma of a plus y.